What's your standard? Even if you didn't do it, you should be able to tell me what's your standard. Pardon? B and D, absolutely correct. Why? Because their vertex is there and their initial arm is there. What's this guy? Lil C, what's this guy? E, what's this guy? This guy. B, this guy. D, this guy. F, and this guy. Good. Like I said, this page needs to be locked in your mind as comfortable as you are with saying the alphabet to go ahead with this unit. Quadrant, where? 1, 4, 3, 1, 3, 2. Excellent. Sketch it. A. Where's it going to be? First quadrant. There. B. Where's it going to be? Fourth quadrant. There. C. Where's it going to be? Third quadrant. Right in the middle. D. Where's it going to be? Second quadrant. Up there. Yay. Reference angle for 170. Pardon me? 10. Reference angle for 345. 15. Reference angle for 72. 72. Reference angle for 215. 35. The other three angles that have a reference angle of 45. Well, if the first one's 45, what's the second one? There's 45 with a reference angle. Where are the other three? There with 45, there with 45, and there with 45. What are they? What's this one? How far is that? 180. How far back did I go? So how big is that red angle? 135. What's the blue angle? I know adding is complicated when you're in the 11th grade. I'll give you some time. If you need some paper or you need an abacus, you need to get out your calculator to add, I'll wait a moment while you figure it out. What's the blue one? 225. What's the gray one? 315. I know if you didn't do it, you don't have an answer written in front of you. But if you're going to sit there and tell me that in the 11th grade and you can't add, there's the door. B. What's the next one? 120. What's the next one? 240. What's the next one? 300. What's the next one? 150. Please, somebody add 30 to 180. Thank you. And 330. What's the next one? 105. Thank you. If the reference angle is 72 and I'm in quadrant 4, what is the actual angle? 280. 288. If the reference angle is in 56 and I'm in quadrant 2, what is it? 124. I heard somebody say it. If the reference angle is 18 and I'm in quadrant 3, what is it? 198. And if the reference angle is 35 and I'm in quadrant 4, it is 325. Ladies and gentlemen, if you do not understand this page and you can't do it as fast as I just did it, you're not ready to go on. That's why I assigned it to you. We are coming up to the end of the year. I am well aware that as teenagers, you shut your brain off at least a month before the end of school. I recommend you get out of that habit. Because whatever you decide to do after here does not go 10 months of the year. It goes 12 months of the year. And your bosses will expect you to achieve exactly as you did in January, in March, and then again in May, and then again in June, and then again in August. Done, Rhea? Bring it to me so I can mark it. Everybody else, have a look at that. You know what? Let's do another few to make sure. I want you to do number 6 and number 7 with the following values. And then number 7, you're going to do 5, quadrant 3, quadrant 4, 27, 16, quadrant 2, and 83, quadrant 3. Do those 4 while I mark Rhea's test. What's 42? 138, 222, and 318. What's 68? 112, 248, 292. What's 89?
269, 271.
10. 35 an angle in quadrant 3. Pardon? 215. 27 in quadrant 4. 333. 16 in quadrant 2. 164 and 83 in quadrant 3. 263. Now I believe you, kind of. Let's take a pause on I think it's 153. No. Is it? Okay, this is a test. I'm going to look around and see how many people's hands move. Draw me the initial arm of an angle in standard position on your page right now. Just draw the initial arm of an angle in standard position. Right on your notes, up at the top, right up here. David, did you hear the silence when I did what is 7 minus 6? Because I heard the silence. It was frickin' deafening. And David, I did not see everybody's hand drawing a line right now. So apparently it was difficult for some of us. Excellently done. Now, draw the terminal arm of that angle in standard position and draw it in quadrant 1. As long as it's in quadrant 1, did you do what I asked? Yeah. So will you get the A? Good. Did you put your angle out here? Excellently done, ladies and gentlemen. Now, put a dot somewhere near the end of the terminal arm. Did you put your dot somewhere out here? Spectacular. Now, what are the coordinates of that dot? Coordinates need an X and a Y. What are the coordinates of that dot? This is the first bit of a trick question I'm giving you. Liam. Exactly. So what are the... Thank you, Emma. The coordinates of that dot are X, Y. Like the coordinates of every dot anywhere on this structure. Right? Everyone agree? Okay. What did I make right here? An angle. What do we call that angle with which we are concerned? Theta. Lovely. Can I do trigonometry on theta right now? No, because I don't have what? Nope. 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 You don't need numbers at all. What do I need to do trigonometry? A triangle. Now, do I have something I can do trig with? Excellent. If I wanted to do trig with theta, I would need to know 3 values. What are they? You do know because you've done trig already. What are the 3 values you need to do trig? Pardon? Opposite, adjacent, hypotenuse. Where from this theta is opposite? The black line, the red line, or the blue line? The black line, yes? Excellent. How long is that black line? Somebody said X, somebody said Y. You had a 50-50 shot. Which is it? Y, because it went upwards. How long is that red line? X, because it went across here, yes? Does everybody understand that? No matter what these values are, I know that one is Y and that one is X, correct? Which means, right now, what is tan theta? Last year, what was tan theta? Opposite over adjacent. Now that we are on the coordinate grid, what is tan theta? Y over X. Right? Everybody understand? Excellent. What then is sine theta last year? Opposite over hypotenuse. What is it this year? Y over. How would I find that value? Who is our best friend from back in the Greek days? Pythagoras. And this distance is what? X squared plus y squared square root. What is cos? What did it used to be? A over h. What is it this year? X over square root of x squared plus y squared. Now this is a particularly cumbersome expression, isn't it? I don't wish to say y over the square root of x squared plus y squared. Do you? Of course not. Do math guys? Of course not, because math guys we know are lazy, right? So, let me show you something. First, don't write this down, just use your brain. What if I went this way? Now where is theta? It's here, yes? Right? Because technically we start here, agreed? But we can't do trig on that because there's no 90-degree triangle. But is there another reference theta here? And is that reference theta going to have an x and a y value up here? Will that y be positive or negative? It will be a positive y, yes? What will the x be? Negative x. Everybody cool? What will this green line be? I should have used a different color. What will this green line be? Absolutely correct. But what is negative x squared? Negative x squared and x squared. What do you know about those two? They're the same thing because a negative squared is positive, yes? So is this green line, because I used x and y, exactly the same length as this blue line? Yes. Is it positive or is it negative? This green line, is it positive or negative? Positive. Why? Because as soon as I square a negative, I get a positive, don't I? Everybody understand? Okay, now, what if I took this line out here? And what's this point now? Negative x, negative y, correct? Does this line change? It's still positive, isn't it? Now, you're intelligent young people. What's going to happen when I put in the last line? What's this going to be? Still going to be positive, isn't it? Now, what is the title of this page? The unit circle. What did I just make? If it was all measured correctly, what is that big blue thing? A circle. Where is its center? Right there, yes? So what are all of these lines? They're all radii. And every radius in a circle is what? They're all half the diameter, but what else are they? What do I know about this distance, this distance, this distance? They're all the same, aren't they? So now, instead of saying x squared plus y squared, what does this become once I draw that circle? What is this now that the circle's been drawn? It's a radius. So it's not over x squared plus y squared. What is it really? Y over r for radius. What's this one really? X over r for radius. And this one is still y over x, yes? Now, how do I find r? We already know. R equals the x value squared plus the y value squared, and I square root. Everybody cool? So now, if I have any point with x and y, can I find the sine, cosine, tan? Yes, because sine is y over r. What's r? This. Cos is x over r. What's r? This. Tan is y over x. What's y over x? You've got them right there. Does everybody understand? Now, let's fine-tune that on this giant one. What are all of these blue x values? They are what? Positive x's, yes? What are all of these dark blue x values? They are negative x's. What are all of these light green y values? Positive y. And what are all of these dark green y values? Negative y. Agreed? Okay. In quadrant 1, draw a terminal arm. Everyone agree? Every dot on that line is what? An x and a y, yes? Put a dot, x, y. X, y, agreed? Both positive, yes? So in quadrant 1, sine is y over r, correct? Is the y positive here? Is r positive? Is r always positive? So in quadrant 1, sine must be positive, agreed? What about cosine? Cosine is what now? It's no longer a over h. What do we use instead? X over r. Is r positive? Is x positive? So cosine is positive. What about tangent? Tangent is now what? Y over x. Are they both positive? So is tangent positive? Yes. Now, draw another terminal arm in quadrant 2. What is this x? Negative x. What is this y? Positive y. So what is sine over here? It's y over r. Is y positive? Is r positive? So is sine positive? Excellent. What about cos? x is negative, so it would be negative x over r, correct? So what is cos? Negative. What is tan? Y over negative x. So tangent is what? Negative. I think you know what's coming. This was quadrant 2, correct? What do you think's going to happen in quadrant 3? Draw a line. Put your x and y. What is that guy? Negative x, negative y. So what is sine? Negative y over r. So sine is negative. What is cos? Negative x over r. So what is cos? Negative. What is tan? Negative y over negative x. What do two negatives make? Positive. And lastly, like I said, I think you know where I was going. What's that guy? What's that guy? X negative y. So what is sine? So what is it? What is it? Negative. What's cos? X over r. So what is it? What's tan? Negative y over x. So what is it? Negative. Now notice, please. Oops. Quadrant 4. What is positive in quadrant 1? All of them. Oops. All. What is positive in quadrant 2? Sine. What is positive in quadrant 3? Tan. And what is positive in quadrant 4? Cosine. Please notice that gives us a new thing like SOHCAHTOA. Some teachers read it clockwise. A-C-T-S. Acts. Some teachers read it counterclockwise, starting with C. C-A-S-T. I don't care, because I don't use that. I know what it actually means. But if you like mnemonic devices, use one. Everybody cool? Everybody understands why it works? Everybody understands why it works? I personally like acts because you start in quadrant 1. And we go clockwise, which makes sense to me. I like this one, if I were to use one. Everybody cool? Now let's put this into practice a little bit, shall we? Turn the page over. We are going to do 3 things here. 1. What's that for? X or Y? X. What's that? 0. Y. That's step 1. Label them all. Step 2. Put them all on a graph. Where is 4, 0? Where's 40? Right there, yes? It's on the initial arm. So is there any angle at all? So this guy is 0 degrees, correct? What if I go all the way around? Now what is he? 360 degrees. What if I go around again? Now what is he? 720. You guys have played enough Shaun White snowboarding. What's the next one? The name of the game. 1080. All right. So, what does that tell us about the sine, cosine, tan of 0, 360, 720, 1080, and so on? What do you think that would tell us? That they are all what? The same. Excellent. Good. So, 0 degrees. Now, that's 2. We've put it on a graph. Step 3. Tell me the sine, cosine, tan. What is the sine? It's y over r, yes? So I better find the r first, yes? R equals the square root of x squared plus y squared. What's x squared? 16. Plus 0? 16. Square root of 16? 4. So the sine here is 0 over 4, which is 0. Let's check. Sine 0. What's the cos? Cos is, you just did it on the page before, it was 2 seconds ago. Cos is x over r. Well, we know r is 4. What's x? 4 over 4, which is 1. What's tan? Tan is y over x, yes? So what is it? 0 over 4, which equals 0. Everybody cool? All right. What's this one going to be? 0, 3, right there, yes? So that is what angle? That is 90, correct? Okay, tell me what they are. What is the sine? What do you have to find first? R is what? 0 squared plus 3 squared, square rooted. What is it? 3. So what's the sine? 3 over 3, which is 1. What's the cos? Which is? And what's the tan? This is a tricky one. 3 over 0, which is what? Undefined. Doesn't exist. Can't divide by 0. Now, obviously, you should have seen a pattern here. If one of these is 0, what's the r automatically? The other one. So what's the r here? 5. No, not negative 5, because r can't be negative, because we're squaring. What's the r here? 2. And then you should be able to do them, yes? This one is negative 5, 0. So it is 180 degrees. And you should be able to do that, yes? What are they? It should take literally 2 seconds. What is sine? Sine's y over r. 0 over 5, so it is 0. What's cos? Negative 5 over 5, so it's negative 1. What's tan? 0 over negative 5, so it's 0. And lastly, 0, negative 2, that's down here. So that is all the way around, and that is 270. What is sine? Negative 2 over 2, which is Negative 1. What is cos? Which is 0. What is tan? Which is undefined. Now, why did I do there, and there? So we would increase by 90. Now, when we did acts, we only talked about in the quadrants, yes? So why did I do these? These are the borders. Everybody understand? 90 is crucial to trigonometry, which you will see more of next year. Everybody cool? Now, you've seen that it works, yes? So let's do it without perfect numbers. Do I need to draw this anymore? Why not? What's this? X. What's this? Y. So x equals negative 4. Y equals 11. What's my r? Square root of what? 4 squared, because I don't have to care about the negative because I'm squaring, plus 11 squared, which is the square root of 16 plus 121, which is the square root of 137. Now, do I want that decimal in math class, or do I want it left like that? I want it left like that in math class. You don't have to simplify it in trig. You can just leave it. So, what then is sine? Sine is y over r, so it is 11 over what? Root 137. What is cos? And what is tan? Which is? (11 over negative 4). Now, notice I also want the angle. Which of those three is easiest to use to find the angle on your calculator? Why tan, Noah? Because you can just punch it in, right? You don't need to do square root of 137. How do you find an angle? Shift tan, bracket, 11 divided by negative 4 equals what? You all have your calculators. What is it? You really need to watch this video. Oh, crap. It's 27. Finished up. Sorry. I forgot with Rhea, too. 70 degrees. Does that make sense? 70 would be right here. Does that make sense? Thank you. Shift, tan, 11 divided by negative 4. Negative 70. Write that down because we're going to talk about it in a minute. Negative 70 degrees. What? All right. We know that this has to be a theta, yes? So it would have to be there, 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 or there, correct? Everyone agrees? All right. Sine is positive, cos and tan are negative. Where is the only place that that can happen? Which quadrant? Quadrant 2. So it has to be this line, yes? We can only do trig with the right angle triangle, yes? So this must be the 70. And that makes sense, doesn't it? Because negative, right, we would go clockwise, yeah? So this is 70. So what then is theta? If the reference is 70, what's the theta? 110. Everybody understand? Don't worry, we're going to do a couple. Let's look at the next one. Soon as I see coordinates, what do I have? I have x and y, which means I can find r. What is r? 4 squared plus 3 squared, which is the square root of 16 plus 9, which is the square root of 25, which is 5. Yes? Great. Now, what is sine, cos, tan? What is sine? Negative 3 over 5. What is cos? 4 over 5. And what is tan? Negative 3 over 4. So, now we got to sketch it. Where is 4 negative 3? Which quadrant? Out 4, down 3, yes? So this is my angle. Where do I start counting from always? Here, yes? This is theta. But I need to find my calculator to do that, yes? Could I use any of them this time? Because there's no square root, yeah? So somebody with your calculator, tell me what your calculator gives you. Ms. Doan, what can I do for you? What is your values on your calculator? I hear negative 36. Do I have anything else? I get a 36. Of course you press shift. You're trying to find an angle. You got 36. What did you punch in? You did cos, because there was no negative. You want to push one less button, right? So that gave you 36, right? Okay, that would be right here, wouldn't it? But since the other two are negative, it can't be there, can it? It has to be down here, which means what's this in here? This is the 36, yes? Is that my theta? No, because theta's got to come all the way around. So theta equals what? 360 minus the 36, which is 324. Does everybody get it? That's why you have to know the quadrants. Because your calculator doesn't know the quadrants. It doesn't know where you're working. You do. Which is one more reason to prove to you that just being able to mash buttons on your calculator is not doing math. Turn the page over. You ready to try this? What are we told in this question? I've been given tan, yes? What is tan? Which way does it go? Y over x, yes? So this must be a y value, yes? And this must be an x value, yes? And I know it's in quadrant 2, agreed? Where is quadrant 2? Right here, correct? So the y has to be 9 or negative 9, and the x has to be 5 or negative 5. Well, if I'm in quadrant 2, which is it? This has to be the negative 5, And where does the 9 have to be? Up. Agreed? Now, can I use that value and my calculator to get a theta? What would I punch in? If I have the fraction, how do I get the angle? Shift tan of what? Or negative 9 over 5. We're going to get the same answer, aren't I? Negative 9 divided by 5. And what does that give me on my calculator? Negative 60? Negative 60. Where is that? The trig is being done here, isn't it? So where's the 60? Has to be the reference angle, yes? Well, then, what is theta? Theta equals what? 120. Everybody see what I'm talking about? Now, when we do this, these 8, you're going to see what I mean. Use your calculator. 4 decimal places. What is sine 43 on your calculator? Got to push 3 buttons. What is it? Pardon me? 6819. 6819. Great. What's cos of 170? Negative 9848, right? I don't even care if you're not rounding this right. There's a purpose here. Please write all the numbers right near the top. What's the cos of 350? Pardon me? 9848 again. What's 10? Or D, I mean. 4817. What's 223? Sine 223. Point 1763 for tan of 10? All right. 0.1763. What's the next one? This shouldn't be confusing. I should be hearing 30 people saying 4 numbers right now. 317. $270. I know. And tan of 190. Now, what do you notice in there? Which two have the same answers? E and F and B, no, not B and C. D and H. Let's talk about Y. We'll do the first one in blue. Where is 223? What quadrant? Third quadrant, down here, yes? 223 all the way. What's the reference angle? I'll help you out. Subtraction's hard. 43. Where is 317? What quadrant? Fourth. What's the reference angle? 43. See what I'm saying? No homework. We'll pick this up again tomorrow.